Welcome to doassignment-ca. Here is the problem. Two boxcars A and B have weights of 20,000 pounds and 30,000 pounds respectively. They are freely coasting down an incline when brakes are applied to all wheels of car A. Determine the force in the coupling C between the two cars. The coefficient of kinetic friction between the wheels of A and the tracks is mu sub k equals 0.5. The wheels of car B are free to roll. Neglect wheel mass. The incline is a 1 in 10 grade, meaning tangent of theta equals 1 over 10, so sine of theta equals 1 over the square root of 101, and cosine of theta equals 10 over the square root of 101. Solve using single resultant normal forces on A and B. Now, let us work through the solution step by step. Here is the setup. Car A weighs 20,000 pounds and car B weighs 30,000 pounds. The incline is a 1 in 10 grade, giving sine of theta equal to 1 over root 101 and cosine of theta equal to 10 over root 101. When brakes lock car A's wheels, a kinetic friction force acts on car A while car B continues to roll freely. Our strategy is to first find the common deceleration of the whole system, then isolate car B to find the coupling force C. First, compute the key forces. The normal force on car A is its weight times cosine of theta, which is 20,000 times 10 over root 101, approximately 19,900 pounds. The kinetic friction force on car A's locked wheels is mu k times n sub A, which is 0.5 times 19,900, approximately 9,950 pounds, acting up the incline. The total gravity component of the combined system along the incline is 50,000 times 1 over root 101, approximately 4,975 pounds, acting down the incline. Applying Newton's second law to the entire two-car system with positive direction down the incline. The net force equals the gravity component minus the friction force. 4,975 minus 9,950 equals the total mass times acceleration. Solving, we get A equals negative 3.20 feet per second squared. The negative sign confirms the system is decelerating. The acceleration is 3.20 feet per second squared directed up the incline. Now isolate car B. Since its wheels roll freely, no friction acts on it. The only forces along the incline are its weight component of about 2,985 pounds pointing down and the coupling force C pointing up the incline. Applying Newton's second law for car B, 2,985 minus C equals the mass of car B times the acceleration of negative 3.20 feet per second squared. Solving, C equals approximately 5,970 pounds in tension. We verify the result by analyzing car A alone. The forces on car A along the incline are its weight component of about 1,990 pounds down, the friction force of 9,950 pounds up, and the coupling reaction C pointing down the incline. Setting the sum equal to the mass of car A times the acceleration, we solve for C and again obtain approximately 5,970 pounds. The answer is confirmed. The coupling between the two cars carries a tension force of approximately 5,970 pounds. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.